Hi everyone, welcome. Hi everyone, welcome back to my channel. Today we'll solve the problem of the day. So the problem is minimum limit of balls in a bag. It's a middle level problem that tests our ability to use binary search effectively. Okay, the code. So the problem is solvable by using binary search operation. So let's dive in. Imagine we have a bag of balls represented as an array, and a certain number of operations we can perform. Each operation allows us to split one bag into two bags, and our goal is to minimize the largest number of balls in any bag after performing all the allowed operations. Okay. For example, if you have the input 9 from the first example, with maximum operations 2, we can split the bag 9 balls into 6 and then into 3 3. The largest bag now contains 3 balls, which is our penalty. If the input is 2, 4, 8, 2, that is from the second example, with maximum operations 4, we can split statistically to make the largest bag contains only 2 balls. Okay, so let us dive into the approach to solve this. We use binary search. Is the data we want to minimize the penalty. So we will search for the smallest possible maximum number of balls a bag can have. For each potential maximum value, we will check if it's feasible using a helper function. The helper function calculates how many operations we need to ensure no bag exceeds a given maximum. Okay, so let me walk you through the code step by step. So we have to define a helper function. So the function name will be the is possible that calculates the number of operations required for a given maximum number of balls if it exceeds the allowed operations if not feasible. Okay. So the second thing is we are implementing the binary search operations. We set the search range between 1 and the maximum number of balls in the array. Then we use binary search to find the smallest feasible maximum penalty. Okay. Okay. So I think you got the logic. So let's dive into the code. As we discussed before, we have to do binary search from 1 to maximum element inside our input nums array. My left will be 1 and my right will be the maximum element inside the given nums array. So how can we find the maximum element inside the array? So there are mainly three procedures to find the maximum element inside the array. So the first one is we have to traverse through the each and every element inside our given array. And the second thing is we simply converting our integer array into a list and can perform a predefined operation that is called collections dot max operation to find the maximum element inside our list. So that is so the what is the list? So the list can be obtained from converting our integer array. Okay, clear. And the third thing is by sorting the nums array. So by sorting the nums array, we can get the maximum element, get the last index position. Okay, can get our maximum element in the last position. Yeah. So let us begin our binary search operation. My left shall be less than right, and we have to calculate our mid value. And mid is equals to left plus right minus left by 2. Okay, this option can so generally we have so generally we used to calculate our mid value by low plus mid by 2. That will also fine, but this will handles our edge cases. Okay, and we have to check if the mid value is valid or not. So the valid so is valid is my helper function to check if my mid value is feasible or not. Feasible in the sense that now we can divide the maximum value with the mid or not. If it is possible, then we have to check for the another element which is maximum, which is minimum. Okay, if it is not valid, then we have to check from the another from the in another part. in another part of our array. Okay, end of the day we have to return the left, which will points our minimum number of balls inside that. So let us write the helper function. For that we require our mid value and max operations. So I'm declaring a count variable. So the logic is so simple and it's checking the mid value is feasible. That in a sense, my mid is possible in dividing the value I inside our num set. Okay. If it's satisfied, then we can increment our then we can then we can increment our count. End of the day, we have to check if my mid is valid or okay. So this will carries this will carry the required partitions that we have that we need to do partition of this particular element. Okay, if the needed operation size should be less than or equal to our max operation that was given in the problem. If it is exceeds that, in the sense our mid is not valid for doing these operations. Okay, I think the logic is a bit a bit confusion. Okay. But no worries, if you watch the video once again, you can easily get the logic. This problem also helps in learning binary search and using binary search in effectively. I think it will work. Yeah, yeah, the code is worked. Okay, if you found this video is useful, please hit the like button and subscribe to my channel for getting some more videos. Uh, if you don't understand the problem, please visit the video once again and check. Okay, that's all for today. Meet you We'll meet tomorrow. Thank you. Bye.